In this section, we're going to talk about hypothesis testing. Hypothesis testing, we extend our exploration of inferential statistics. So we talked about estimating a population parameter. Now we're going to talk about making a decision about that population parameter. Okay? So hypothesis testing, we talk about our statistical tests. So when we do hypothesis testing, we actually have 3 different types of tests. And in these tests, we have what's called the null hypothesis and the alternative hypothesis. So the null hypothesis is H with a subscript of 0. We usually say this H naught. And the alternative hypothesis is notated as H with a subscript of A. Some books use a subscript of 1 here. If you watch any of my videos previously, I do have a subscript of 1 here based on our other book that we used. Okay, so the alternative hypothesis is what we're going to be testing. Okay, I have this kind of up here, but it's really, we're going to be testing the alternative hypothesis, and the null is going to be assumed to be true. Okay, so oftentimes when we talk about hypothesis testing, when I teach this in the classroom, I talk a little bit about for example, if we're in a courtroom. Now, keep in mind my knowledge of the legal system really is limited to law and order and things like that. So just my limited knowledge of that. But most of us know in our court system that we have, if you're accused of wrongdoing and you go to court, or let's say a trial, we are assumed to be innocent. So if I was accused of stealing my friend Fred's calculator, okay, and I go to let's say a court, we're just pretending here, a trial, I'm assumed to be innocent. So what Fred has to do, or Fred's attorneys have to do, is find enough evidence beyond a reasonable doubt that I stole the calculator, right? So you're assumed to be true, or assumed to be innocent, unless you have enough evidence to prove that you are guilty. So think about it this way too. Our null hypothesis is assumed to be true, and we're trying to find enough statistical evidence to prove the alternative. Okay, so in our court system, we're assumed innocent, and we have to find enough evidence to prove us guilty. Okay, so at the end of the court system, or at the end of the trial, right, you never have to prove your innocence, right? You're always assumed to be innocent. We have to find enough evidence beyond a reasonable doubt to prove that we're guilty. So that at the end of the trial, when they say, Foreman, what say you? They say we find the defendant. They never say innocent, right? They either find him guilty or not guilty, right? So basically this is true in hypothesis testing. We're either going to find enough statistical evidence to reject the null hypothesis or not reject the null hypothesis. Okay, so when we reject the null, it's like we're saying they're guilty. Okay, when we reject the null hypothesis, it means we found enough evidence to find the alternative true. When we say not guilty, it's like we're saying do not reject the null hypothesis. Or in Newton, they use the words fail to reject. Okay, I like to say do not reject because it's kind of like the not guilty. So when we say not guilty, it didn't mean we proved you were innocent. It's just that we didn't have enough evidence to prove that you were guilty. Same thing is true here. When we say fail to reject or do not reject, it just means we do not have enough statistical evidence to reject the null. Okay, that's kind of my little theoretical overview. So let's talk a little bit about the types of tests we can have. we can have what's called a right-tailed test, a left-tailed test, or a two-tailed test. So you're not going to have all of these. You're going to have one of these tests. Okay? So a left-tailed test is when the alternative is that we're testing if our population mean is greater than 10. So really the type of test you have is looking at the alternative. And basically this helps us when we, and I'll show you here in a little bit, when we do our critical region, which is how we determine what our decision is where the tail is. So think of it, it's wherever your alternative points. This points to the right tail. This one points to the left. So this is a left-tailed test, right? Okay. This one, because it's not equal to, is a two-tailed test, meaning our rejection region is in both tails here. Okay. So we usually set up, when we go to set up our null and alternative, we look at what we're trying to test. Okay. What we're trying to test is the alternative. So if we're trying to test that the population mean is greater than 10, then we write that first, and then the null is just the complement of that. It's less than or equal to. If we're trying to test that the population mean is less than 10, then the null is just the complement of that mu is greater than or equal to 10. If we're trying to test that mu is different than 10, not equal to 10, then the null is just the complement of that or equal to 10. Okay? So we're only going to pick one of these tests to do when we do our hypothesis testing. All right, so when we see some examples, it might make a little more sense to you here. Suppose you want to test whether the distance to Rhodes State College of the students is less than 10 miles. Okay, so we think about the alternative first, that the average distance or population mean distance is less than 10 miles. That's what we want to test. So the alternative is less than 10. Well, then the null, okay, is the complement of that or greater than equal to 10. The equal sign is always in the null hypothesis. Okay, so would this be right-tailed, left-tailed, or two-tailed? Well, we look at the alternative. Which way is it pointing? It's pointing to the left. So this would be a left-tailed test, okay, when we do our critical region. Okay, all right, before we do a full example here of conducting hypothesis tests, I want to talk just briefly about the type 1 and type 2 errors. Okay, and this little table here kind of shows what a type 1 and type 2 error is. Okay, so if our null hypothesis is true, okay, and we don't reject it, we never say accept here. We always say don't reject or fail to reject. Either one. Never say accept, okay? So if it's actually true and we don't reject it, then we made a correct decision, right? Okay, however, if we reject the null, but it was true, we made a mistake, right? We made what's called a type 1 error. So back to my legal thing, if you're innocent, remember you're assumed to be innocent. If you really are innocent, but we said you were guilty, we made what's called a type 1 error. Okay? If you were guilty, okay, and we said you were guilty, if the H naught is false and we reject it, that's a correct decision. But if you were guilty and we said not guilty, we made what's called a type 2 error. Okay, the probabilities are associated as alpha and beta. Alpha is how we're going to determine some of our rejection region down here. So you can kind of look at this table when you're doing some of the homework problems here. So let's look at this one. Suppose the null hypothesis, H naught, is that Allen's alarm systems are safe. Okay, so the null is that they're safe. So what is a type 1 error? Okay, a type 1 error is they really are safe, but we say that they're not safe. Okay, that's called a type 1 error. A type 2 error would be Allen's alarm systems really aren't safe, but we said that they were. We did not reject it. Does that make sense? So I would suggest maybe looking at this table when you're doing these problems, determining the type 1 and type 2 errors. Okay, let's look at an example. So with the hypothesis testing, what I recommend and what I'm going to have you do on the weekly test and our final, our exam 2 and our final, is these 5 steps. Now in Newton, it'll ask you bits and pieces of these. So what I'm going to do is go through an example using all 5 steps.